In addition to the automation of the tilemaps we've done last episode, let's now update the UI panels. Currently they are manually created, but whenever we would add new buildables, we also need to update the UI, which is quite annoying. But good thing is, it's not that hard to code, and UI coding stuff is always good to know. So let's start. According to our current UI scheme, we want to have UI categories, and they contain the button tiles to draw. Theoretically, we could reuse the category ScriptableObject from the previous episode, but UI handling for the user and Tilemap code handling can be completely different. So it's more practical to separate this and create new UI categories in form of a scriptable object. Change mono behavior to scriptable object and also add a line to add this item to our context menu. Now I'm going to add two variables with their getters. The first one is the sibling index and is just an integer. This number represents the order of our categories from top to bottom. The second is of type color and will change the background color of the category labels. Currently they are all white, and this feature is basically just for show and acts as an example how you can change various things. We now have two options. Every UI category could have a list of buildables, which then will be shown. Or we reverse this by assigning the UI category to the object itself, like we've done it with the other category. I'll use the second approach because I think it's better to store information that belongs to an object there. It also makes sure that an object is only shown once and can't be assigned to several categories. So let's add the according field and getter to the BuildingObjectBase. If you named your new scriptable object differently, just make sure to also change the type. Now let's create some UI category and then assign our buildables to them. The sibling index starts by 0 and represents the entry on top of an hierarchy, and therefore at the top of our list. Then just count upwards. When choosing a color, make sure to increase the alpha. It always starts with a default of 0 and that makes it invisible. Then just fill in the new field we created for all the buildables. I decided to not create an item UI category so that we can see some differences. Like we initialized the tile maps on game start via a script, we now need to do this for our UI. I create a new script called BuildingHUD because it only represents the UI elements that are responsible for building. Make it a singleton and also import the UnityEngine.ui package. Now, taking a look at our current structure, we have the following. The wrapper, which contains the different UI categories, here called categories. In there, the category element, which itself contains the category label, here badly named background, which represents the background and the title of the category, and also the list of buildables, which are the buttons we created in episode 1. To spawn objects with this structure, we are going to work with prefabs. To create those, I will change and rename one of the existing categories. This will act as an universal start point for all the elements we will spawn later. Make sure to remove the content of the items, because they will be spawned into this separately for every entry. The text of the title will be changed as well, so there's just a placeholder ABC for now. When done, create a new folder called Prefabs and drag and drop the object in there. Now this is our category prefab. To spawn the button, we need another one as well. I'll adjust an example entry like earlier and remove the specific values like the image and the building reference so that it's just a blank building button. Now drag and drop it into your prefabs folder as well. I move both entries to an UI folder so that it gets obvious where the prefabs belong to. Now that we have what we need, let's create the according serialized fields for this, so we can set up the UI creation. Of course, we want a list of UI category to select the categories we want to display. This is done manually but could also be done via code so that you can show different field groups for different needs. Then we need the parent element, where all our categories go into. If you want to set a parent for a game object, always use type transform for the parent. This will automatically get a transform component of the game object you will drag into the slot. And of course, our two prefabs. So the upcoming part might be a bit difficult, so let's do it step by step. I create a method which will build the UI and will be called on start. I create a for each loop to iterate through every category inside the categories list. So let's instantiate a new object based on the universal category prefab. We then set the wrapper element as parent. So basically that spawned our category object. Let's change the hierarchy name to the current category name so that we can check if it works correctly. Back in Unity, add the script to your manager object. Add the wrapper element and the two prefabs. Now add all the UI categories you want to show. I also hide the prefab and remove the manually created entries so that they don't disturb the new creation. When starting play mode, the 3 entries get created. Taking a look at the hierarchy, you can see they were named like the category and contain the structure like we want, so the basic setup works. Since we want to add the buttons to those instantiated elements here, it makes sense to save the instantiated objects reference to the category they belong to. This can be done with a dictionary. As key, we use the UICategory, and the value will be the game object we created. So after initialization, you can add the key value pair to the dictionary. In some use cases, for changes during runtime, there might already exist this element. So let's check if the current key, the category, exists in the dictionary. If it does not exist, we create the entry and add it. Else, we assume it was created earlier, but based on how the code currently works, this will never be the case. Just be aware of this handy approach if you add live update later on. Now, whether the if statement was executed or not, we have a value for the active category. We then can replace the call of the inst variable with the game object, which is saved in the dictionary, because basically they are the same. Now we can change the other attributes, like the text, which represents the name of the category. For this we will find the first and only text component for the game object. Make sure to use getComponent, not getComponents in children. Changing the index is quite simple and will make sure that the one with an index of 0 will be on top of the hierarchy. Changing the background color is similar to the text, but we will get another component, of course. If you have several text components, for example, you might need to get the correct ones based on their direct parent or their position. An example of the latter one can be found in my tutorial about the UI for the high score list. On testing, all 3 elements have now a background color and a according title. But of course the items are still missing, so let's fix this. Since we reverted the reference between category and item, we don't have a simple list of objects we want to show now, unfortunately. One approach now could be to have a serialized field where we add all the scripted objects we created, and then we can loop through them. But who would want to do this? It would be much cooler to just use all the scripted objects that are located somewhere inside the according folder, right? Right. The good news, Unity can do this. The bad news, this only works in a folder called Resources. Let's just take it as it is and create a folder. We then can move our complete Scriptables folder in there. I think all bad news should be so easy to fix, huh? So back in the building HUD script, let's create a method which will return all buildables. The return type will be an array of the BuildingObjectBase, or whatever type your buildables are. Then just return resources.loadAll and add your type as type reference. As parameter, you then can specify the path where they are located. Be aware that the resources folder is used by default, so this must not be added to the path. We then can call this method right after the loop where we created the categories. Then we can iterate through all buildables. When creating a button, we need to assign its parent correctly, which is the items object inside the category prefab, which is empty for now. Every parent might be used several times, so it's better to only search it once and then save it into a variable. I'll do this by saving it into a dictionary, with the according game object as key. The value is of type transform, because this is the type we need for setting a parent. Right after I instantiated an object and filled the first dictionary, I also set the key and value for the new one, the element item slot. With the find method, I can find objects by name. So we can now find the according value with the key, which is the game object. To get the game object, we need to look up in our first dictionary with the UICategory key. You can nest it like this. This will return the items object for the current UI category. But spawning an item which is not assigned to any category would be bad. So let's make sure an UI category was selected. If this is not the case, we will skip the rest of this code and continue with the next element in our loop. Now we can instantiate a new object like we did earlier with the category prefab, but now we use the one for the item. Then we can set the parent to the parent element we retrieved 2 lines above. Then you can change titles, names, and sprites. There is only one problem with the image. We want to get the sprites that are assigned to the tiles we created in episode 1. But we don't have an object of type tile, but rather tile base. And the latter one does not expose a sprite property, but a tile inherits from tile base. So that's the reason why we can use the tiles here as tile bases. To get access to the sprite property from the tile, we just create a temporary variable of type tile. For this, import the Unity engine.tilemaps package. With an explicit conversion, we can convert the tile base variable that comes from the current buildable to a tile. Now we can access the sprite property and assign it. And we also need to assign the buildable itself to the building button handler script. Make sure to add a setter for item in the script. Now you can assign the item via code. So now for every existing buildable inside a given path, we will check if it belongs to an UI category. If it does, the object will be spawned and it gets added to the according category. That's it. When starting play mode, everything should look like earlier, but with a little more color. You can see the items exist. They have the correct sprite, and they also reference the correct building object. So currently the UI only gets created once during start and not updated, but we laid a good foundation for an updatable UI. If you need this, I recommend to take a look into my high score list video, which contains some useful code parts. In the next episode, we'll take a look into some improvements and useful features for the current code. Thank you for watching, and also thank you to everyone supporting me and the channel. Special thanks to my supporters on Patreon, Patrick and Naxvomo. Thank you all, and as usual, if you enjoy the content, consider liking and subscribing, and I'll see you next time.